Here I have more than 50 PNG images in this folder. I'll run this code and in another folder you can see that all the PNG images have been converted into JPEG images. Okay, we are in VS Code and I opened up a .py file here. I will be importing this time module just for some extra delay because otherwise you guys will see it be done instantly. But you don't really need it. Next, I will import the path module from the pathlib library. Gonna need it for creating paths for files. Then I'm gonna add the image module from the pillow library for opening and converting the PNG images. Here you don't have to install anything for getting time and path modules. They are built in, but you're gonna need to install the pillow library in the terminal for getting the image module. Okay, now let's get the directories from the images as a string into two variables. The R you see at the start is for making sure it is considered a pure string with no escape characters. So things like /t here are ignored by Python. Let's declare a function that takes these two directories as parameters. Then I put them both through the path function to turn them into path objects. This helps to use different methods from the path module. Then I'm declaring some variables. In one of the variables, I take all the PNG images I can find inside the input dir folder and store them as a list, and then count how many is in that list with the len function. Alright, time to use a method called makedir on the output dir. Inside makedir, parents true means it will make up whatever folders are missing in the given path. And with exist OK true, it will help to make sure no issues occur if the folder we are trying to make with makedir already exists. In a for loop, we take the full path of each image and cut out its name by using .stem at the end. .stem only takes the name part of the file and leaves out the extension. Here with the with context manager and the image module, we safely open the image directed by the image path variable. And after accessing the image, use that image as img inside the with context manager block. The with context manager makes sure that an image opened, then worked on, then closed, thus preventing it from not closing properly and helping to prevent RAM overload and program crash if you give it a lot of images or huge images to convert. First, we're gonna check it if it is RGBA color code format. If it is, we move on inside the if block and replace the alpha value of RGBA with the color white. As you can see here, we create the new white background image and give it the same size as the PNG image size. Then on top of the created white background, we paste in the PNG image and the mask parameter is set with the fourth value of the given RGBA, pasting in only the colorful pixels onto the white background. After all that, we just pass it off into img variable to now carry the new white background RGB image without the alpha value. And in the else block, if the given PNG image is not RGBA, we convert whatever it is into RGB color code inside the else block. Okay, after all that, our PNG image is ready for conversion, but we will still need a full path including the name for our JPEG image after it's created. So let's get the output directory and join that with image name of the PNG image and add the .jpeg instruction at the end. Then finally we call .save on our image that we opened with the with context manager. Inside .save, give the format you want, in this case JPEG, and set the quality to 90. If you didn't know, when you convert a PNG to JPEG, the image loses some quality or details. So the quality parameter here says how much of the original PNG image quality should Python try to maintain in the new JPEG image. I'm not exactly sure how, but anything over 95 increases the file size a lot without much benefit in quality. Let's increase the count variable value by 1 each time a conversion happens. Then we print the current value after the increment, and we also print out the name of the PNG image we converted. And you know that Python automatically goes to a new line after printing something. Python does that by automatically adding a backward slash n at the end of it all. So we assign the n parameter with an empty string so that it doesn't go to the next line. And flash is for, well, flashing the string down into the terminal instantly without any kind of waiting. Python waits for multiple strings to be ready for showing them all together. Also add some extra space at the end of the string so that you don't end up with the extra letters like this. Anyways, next add a time of 0.1 seconds so that we get to actually see the number go up and not go so fast that it looks like instant 0 to 60 without all that in between. Now I'm adding another print after the loop finishes up.